you so much for joining us for today's webinar, Navigating Treatment Data, Choosing the Right Dataset for Your Needs. My name is Annie Oxerart, and I'm with the Association for Fire Ecology. This webinar is part of the Fire CAFÉ series hosted by the Association for Fire Ecology and is designed to advance understanding and collaboration for important fire ecology topics and issues. I'd like to give a big thanks to Corey Blankenship with the Nature Conservancy for proposing and organizing this webinar, and to our great lineup of speakers. And thanks to Kirsten Peterson, Megan Dettenmeyer, and Aidan Franko for their assistance in helping set everything up. For those not familiar with the Association for Fire Ecology, we are a member-based organization dedicated to improving the knowledge and use of fire and land management. We'd love to have you join us as a member and be involved in our future activities. So please check out our website. And we'd also love to invite you to attend our upcoming event, the Beneficial Fire Summit, which is going to be held in San Diego at the Hyatt Mission Bay the second week of December. There's information coming soon about that for the call for proposals and for sponsorships and opportunities for exhibits. For our webinar today, we have a panel of speakers that will be sharing information on 5 data sets. We'll be hearing from Margaret Farrell, Amanda Rumsey, Kirk Davis, Aidan Franko, Brenda Lundberg, and Andrew Johnson. And then Aidan will come back on and facilitate our question and answer and discussion period. And with that, it is my pleasure to turn it over to our first speaker, Margaret Farrell with the U.S. Forest Service.
Good morning, everybody. Thank you so much for the invite. I am filling in for Matt Tansey, who's the program lead for the hazardous fields for the Forest Service, and I am the account manager for the entire FACTS application Forest Service activity tracking system. Next slide. So within the Forest Service, we do multiple land management. And so with that, many of our actions are primary hazardous fuels. The work is being done strictly for fuels, for the benefit of fuels. And then we have the other activities that we do, such as timber harvest and things like that, which we use as integrated fuels treatment. So in our database, as we are creating all this content, it is known as a key point 3 for primary hazardous fuels and key point 6 for secondary fuels benefits. But we do have the targets that we work towards for the primary fuels integration. It feeds across all the different areas with the emphasis for fuels right now at this time. We're really working on the wildland urban interface areas that we have. And we are also trying to get good integration within our timber areas, our fuels areas. One of the areas we're working on doing more tracking of is targeted grazing and things like that with sheep, goats, and things like that. And those activities are all tracked within FACTS. Next slide, please. So within the FACTS database, we do have over 100 different land management activities. They range from fire, wildlife, fuels. We have reforestation, timber, many of them. But for our fuels accounting, we do manage to treat at least 3 to 4 million acres per year. That's that integration of key point 3 and key point 6. So when we measure our accomplishments, we have the ability as content creators to enter when we accomplish the work, which is when money is exchanged. There's an allocation of funds going one direction or the other. And so for fuels, we track the accomplished date. Within the internal area, it says accomplished. My external data sets that you'll see that we have, the award date is when the work has been awarded to contractors. Doesn't mean that the work is done. It just means that the work has been allocated. Timber purchasers are paying for the removal of the log. And so that is a key point 6 type activity that we track the award date for that. Most of our internal fuels actions that we do within the Forest Service, if it's a primary hazardous fuel, a lot of times that is done by the Forest Service. And so that work will be shown as accomplished, i.e. awarded, and completed at the same time. They may do a prescribed burn. It starts on Monday, it ends on Friday. Oftentimes they will put it in with the same accomplished date as the completed date because the system will automatically put that in for them. But that is a big thing to note as you're looking at our data. Accomplished date means that we have allocated funds. Completed date means that the work has been done on the ground. So that's just one thing to really be aware of. The national initiatives that we have the Joint Chief, which is Forest Service with the Natural Resource Conservation Service. We've got collaborative forest landscape restoration partnerships, and we have several high-risk landscapes. They're the wildfire crisis strategy areas that we are tracking, activities that we're doing within as primary areas for fuel management. We do fuel management areas outside of those, but those are our main targeted areas. Now, as the users create all the content of recording these activities, they have, as they complete the work, the option to fill in a purpose code of final and maintenance. Those are what roll up into our year-end accounting. But there is also an initial or interim that is optional for the users to choose. The initial would be if they're working on something and they've done some thinning, you know, they've done some fuel treatments, they've thinned out the stands, but they still have the piles existing. They haven't mitigated all of those fuels yet. So that would probably be an initial or interim. But when they actually finish burning that area off or burning the piles, then it will be listed as a final so that we know that the fuels have been mitigated at that particular area. As they're doing the prescribed burns and other activities, oftentimes with your prescribed burn, you know, you burn it and you've got a nice final. It's like, yes, we've got those fuels exact where we need them to be. We will come back into that same piece of ground later on, 3 years later, 2 years later, whatever the appropriate interval is, and they will reburn or do other maintenance work on it to keep that fuel loading appropriately. And by doing that, we can take it as a maintenance purpose code just to see the lands that we are going back into and maintaining in that correct fire regime area that we have them for. The Forest Service does do work predominantly on Forest Service lands, but we can do work on adjacent lands, such as state lands, through stewardship agreements and things like that. So some of our data that you look at will include areas that do have state ownership indicated within the data sets as you look at it. We do take our activities and they are crosswalked into the NIFPOR's data set. They go every night. If we've had changes, updates, corrections, new data entries, those are entered in by our folks as the content creators, and it is fed over into NIFPOR's by a feed each evening. Next slide, please. This just gives you an overview on how the Forest Service is accomplishing much of their land management. The really dark colors, mechanical and other, such as those would be oftentimes thought of timber harvest, pre-commercial thinnings, things that we're doing on the ground that benefit fuels, but also benefit other resources. We track the natural wildfire activities that occur. And as we know, a lot of times when you have those wildfires, they do meet prescription. They do clean up the ground appropriately and do good land management with some of these wildfires. And so we do track those acres. And then, of course, we have all of our prescribed burning. As you look at the different zones, the different GACs that we have, you can see the southern area does a huge amount of prescribed fire in comparison to the other areas. So this gives you a snapshot of how the reports came out last year for fiscal year 25 of what was accomplished. Next slide, please. We've got multiple ways of being able to access the facts data. You can go into AGOL, and it is available for all public. There's a hazardous fuels treatment PL for Polygon because all of our activities are in a Polygon feature. And you can bring that down. It has a great little slide rule at the bottom so you can see past activities. You can see what's been entered in as planned activities. And so you can see where we're at with our activities on the ground. But this one is readily available in AGOL. It's hazardous fuel treatment reductions. You will also see one in there that is labeled as a line, LN, because oftentimes if we're doing prescribed burnings and we're putting in that fire line, we are expending funds in 1 year, but the burn may be another year, so that we can track that expenditure of money to build that line. You may see some items in the line feature, but all of our activities, once we've done them and plan them out, things like that, you will see them in the Polygon feature class. Next slide, please. We also have a facts common attributes available for download. That pulls everything, whether it is fuels, whether it's strictly timber, reforestation, the whole data set can be pulled down. It is huge. I've got over 7 million activities in the database. Not all of them are spatial, so not all of them would be captured here. Because some of them are older, we don't have that spatial item. And next slide, please. To get all of our data that you want pulled down, you can download it from data.gov. Here's the item for that, and our next slide. This gives you a picture. This is another one, dashboard that is available to the public that allows you to drill into specific activities themselves. But you can see how the progress is going. This was pulled first part of May, and we're on our way to the 360,000. And realistically, we're at 100,000 about right at this point. So,
everyone, my name is Amanda Rumsey. I am the data manager for the Wildfire Management Research Development and Application Program. So with MURDA program, here with my colleague Patrick Johnson, fire management specialist, but our program is really responsible for the development of the WIFDIS application and the IFTDSS application. So today we're going to talk about the FTEM module that fits within IFTDSS a little bit, and then the Integrated Interagency Fuels Treatment Service, or the ITS, that is used to feed FTEM. So next slide, please. So great. When a fire burns into a previously completed federal hazard fuels treatment, DOI agency staff, so we're talking the new Wildland Fire Service, BIA, BLM, MPS, Fish and Wildlife Service, and USDA, US Forest Service staff are required by policy to report on how that treatment influences fire behavior. This overall reporting mechanism is called FTEM, Fuels Treatment Effectiveness Monitoring. And it's a really important feature because measuring the effectiveness of fuels treatment activities allows us to qualify the value of these federal fuels management actions and investments. Next slide, please. So yeah, here's a little bit of a snippet of the IFTDSS application here. So when you are in IFTDSS, there is the FTEM module, and the FTEM module is what DOI and USDA or US Forest Service staff, employees, and collaborators use to complete their monitoring. So within FTEM, we pull in three sets of data to really figure out those interactions between wildfires and fuels treatment. So we'll talk more about the fuels treatment sides in future slides, but I wanted to talk a little bit about wildfire data. So we pull our perimeters, so polygon perimeters from WIFIGS. WIFIGS is the Wildland Fire Interagency Geospatial Services managed by the NIFC ArcGIS Online org folks, but they have an interagency fire perimeter service that we use to pull in WIFIGS data. There's no cutoff on this service, so it's not just a year's, the current year data. It does go back quite a few years. And in the service, you'll see wildland fire is essentially anything that is derived within Irwin as a wildfire or prescribed fire is validated, or so that it's not quarantined, so it's not a duplicate of other records, and is set to public, approved, and is visible. So we pull in a subset of that data into FTEM, and then we have Irwin, of course. So Irwin is the integrated reporting of wildland fire information. And it's the data orchestrator across our federal community. So it connects systems like WIFDIS and IROC and SIP 209 and many more to integrate data across those systems so that you see the latest data in regardless of what system you're in. So it's really kind of the heart of all of our data within the fire community federal space. And that's where we get our point data. So LANDFIRE point data, we pull in to FTEM, those the subset of those Irwin data points. Every fire you see in FTEM will have a point. And then if there's not every fire will have a polygon. So we do provide both layers in there for staff to look and assess the interactions between it. And then we'll talk about the interagency integrated treatment service on the next slide. So thanks, Corey. Great. So in order to develop this solution reporting system that worked for both, U.S. Forest Service and DOI entities, we needed one single treatment service that incorporated data across both of those system of records, or department system of records. So this is where the interagency or integrated interagency fuels treatment service was born. So it is maintained by our WFMRDA program. It includes FACS, NIFPORs, and now IFPERs, completed hazardous fuels treatment data, and is updated nightly. It's designed originally for intent use within FTEM, but it's also available for wider audiences looking to understand the complete hazardous fuels landscape within the federal space. I would like to say that, it's not an authoritative federal data set. The systems of records, FACS, NIFPORs, IFPORs are authoritative systems of record, but it isn't a federally endorsed data set. So we try to keep our data in line with what's in the system of records as much as possible. And to the right there, you'll see kind of a subset of what that service looks like and the treatment types and categories that we symbolize by. Next slide, please, Corey. Great. So let's talk a little bit about those data sources. So like I mentioned, NIFPORs, this was DOI's system of record for identifying projects, activities, and treatments, and tracking and reporting those kind of nice National Fire Plan accomplishments from early 2000s to September 2023. We did use that service to pull in NIFPORs data. Again, this NIFPORs is no longer the system of record. It's been deactivated, so that service no longer works. But what we used to pull into NIFPORs data existed in that service. And we do query by anything accomplished, what that's labeled accomplished in terms of treatment status on that data. DOI has moved over to a new system of record called IFPERS, the Interior Fuels and Post-Fire Reporting System. Again, it's the new system as of October 2023. We pull from their IFPERS open data feature service, and we use a subset of that data. So if you look at that service, we only pull in fuels data. We're not interested in post-fire. We pull in actual treatments. Again, we're not interested in estimated treatments or estimated activities. We want everything that is completed, has a completion date. It isn't kind of labeled for archiving. I will mention here that between NIFPORs and IFPERs, I said October 23 was the cutoff date. BLM did not move over to IFPERs until October 2024. So there is a little bit of overlap there in between system usage. So just be aware if you're looking at NIFPORs and IFPERs data that exists. And then we have FACS, which Margaret just went over. So this is the system of record for managing information on activities related to fires, fuels, silviculture, and invasive species. So we do pull from their hazardous fuels treatment data, and we want to make sure that it is completed and if it has a revision date, the revision date is null or it's not into the future. Next slide, please. So we do a little bit of data processing on this data, and I do want to talk about it a bit. So for NIFPORs data, as we ingest this data in, we reproject it to Web Mercator to match the output service that we maintain. We merge the data by treatment ID, That way, when users look at that fuel treatment, they see the full extent of those boundaries. We map it to the schema for the ITS, and I'll talk a little bit about that on the next slide. And then we generalize polygons with more than 400,000 vertices. This is something that we do mostly because of Esri functionality. We found that if you have a shape that's over 400,000 vertices, Esri turns on auto optimization, and that auto optimization kind of slugs down the service a bit, especially if you have edit or sync capabilities on. So we try to keep our service out of that kind of danger zone per se. And then we have IFPERS. Again, we do kind of change that projection for processing purposes. We match it to the ITS schema. We generalize that. And then IFPERS just implemented in the past year progressive reporting, allowing people to start reporting their completed treatments in stages as work gets done, not just the whole scope of the planned geometry. So we're going to be updating those models here soon to update for that new functionality built in. And then facts, again, we do those same things. We reproject, we merge, we map it to the IT schema, we generalize, but then we also create this unique treatment ID. So to make a unique treatment area, we merge these IDs by SUID, activity CN, and then the date that activity was completed. So that is our unique treatment ID for what you see in our service. Next slide, please. Great. So let's get into our schema. So I would say our schema is behemoth. I think I just did a count. There's 270 fields in our service, but that's intentional. Our first set of fields align with the NWCG 2014 fuels treatment polygon standard. So if you just need a kind of quick scope of I guess consistent fields across all NIF4s, IFPERS, facts, look at the first kind of subset of 20-ish fields within our service, and you'll find mostly essential the information that you need. We're working again in the next year to update the fuel standard and incorporate new fields into here as well. We have ETL status fields built in, so this is mostly for our processing purposes, and it's an action field and an update date, so that we can tell when these treatments made it into our system and when they were last updated. We got NIF4s, IFPERS, and facts data schemas, the full complete schemas for these data sets baked into this data set. And we preface those fields with N, F, or I so that you can kind of tell which system of record they're coming from. And then last but not least, you got the Esri system generated fields at the bottom. Next slide. Great. So we have some important links here. I'd say check them out. So it's a link to our interagency fuels treatment service. Again, we have a public view. We have, for those on the NIFC org access, there is a sync enabled view for you to take offline. And then we have the IFTDSS Help Center. Our content and help team is incredible. Please look through that if you have any questions there. And then there's the IFTDSS support desk to help out too. But I'll say, that's the data set, and then FTEM, we pull a little subset of, a subset of that data from our treatment service into FTEM. We have fax treatments after 2005, NIF4s treatments for 2008, IFPERS, the whole history as of now. But that data that we pull into FTEM is key point 3 and 6, like Margaret talked about. And we try our best within the FTEM interface to reduce duplicates specifically for fax data, because there's many kind of activities you can perform over on the same set of ground. So we want our users to see the latest data, the latest action or activity that's been performed on that land.
My name's Kirk Davis, and I'm here today to talk about the National Fuel Treatments and GARP project. So these are both initiatives that were carried out by Timmins Group, which is where I work, and on behalf of the National Association of State Foresters. So we will jump right in and We'll start with NFT specifically. I think that that's the most relevant to this group. But we will touch also a little bit on GARP. So just so that folks know, these are two distinct but related initiatives. GARP is a portal for states to report on grant accomplishments from federal funds. And NFT is a place where we're trying to aggregate all hazardous fuel treatments across all land ownerships nationwide. Next slide. So this at its core is really just trying to say what happened where. And again, this is showing like what we're trying to capture. So the fuel treatments is less relevant to this group because you're all familiar, but I do like to show this. So NFT is a geospatial data product. So there's a lot of different pieces that go into making the National Fuel Treatments Initiative what it is. So next slide. At its core, we are just trying to pull data directly from state fuel treatment databases. So these are typically feature services that the states own, and they provide us access to it. We pull from those live sources or sometimes just static sources on a periodic basis, standardize it into the National Fuel Treatment Schema, and then provide a portal for folks to view what their data looks like. Now, a big distinction between some of these systems of record that you've been hearing about from the federal side is that NFT is really just reflecting the current state of treatment data within the state agencies that they reside in. So we try to put all the ownership of the data on the folks from those organizations. And so the burden on them to make changes isn't as high. There's less burden on requesting data. We really just focus on tuning the import of their data into our system, and then the better their data gets internally, the better it gets in NFT. We also aggregate data from federal databases. We have aggregated directly from FACS and IFPERS, NIFPORS, Inform. We've also ingested the integrated interagency fuel treatment service, but we currently are pulling from a consolidated federal data source from the SWIRIs for 3 of those federal data sources. We also have another initiative, which I won't cover here, called the Treatment Tracker, which is a web-based tool and has a field component for agencies that are GIS challenged. Maybe they don't have as much resources or the software licensing. That's a place for them to push data in. So that is like at the highest level what NFT is. So next slide, please. By the numbers, we currently are pulling from 56 data sources. It's important to keep in mind that some of these are static sources, so they aren't changing, and we are constantly working with the state agencies to help pull that data in. You'll notice we now include one non-governmental organization. I did see Tall Timbers on the call. We're ingesting from their Tall Timbers prescribed burn planner tool, which covers kind of like the Eastern US. So we have 42 states that currently provide us services, and we have a nice map that we use to name and shame the folks that haven't given us data yet, in a positive way. And we're just trying to make data as good as we can. The number of how many fuel treatment records we have is not really that relevant because that number fluctuates. And we do sort of cut off the data that we ingest from federal services so that we're not getting the entire history. Our focus is mostly on what's the latest, greatest, because we are trying to tie in the grant reporting. Next slide. So the core components, again, sort of just listed out here. We do keep a database of all the schemas coming from the different agencies and from their data sources. We keep scripts for kind of those, like the one-off static data pulls. And then we maintain 2 ArcGIS Online hosted feature services, which act as our data store and are used in various applications. We back that up and provide an integration point via blob storage on S3. And that is how the SWIRIs, you'll hear from them a little bit later, how they integrate with us. And we maintain a documentation and contributor engagement site where we try to get all of our user information and what we use when we reach out to organizations. And we have this tool called the NFT Metadata Explorer. It's really just to give folks a look and a snapshot in on like what the data looks like coming from their sources as it's been aggregated. The next slide will kind of show you what that, the one after this, but this is an example of how the data is moved from a source system into the schema in NFT. I think it's just good to show folks like, irregardless of what your source system looks like, we can integrate it and we will manage and maintain the mapping. And so really like a lot of this, the success of NFT comes from communicating with the data owners in the state agencies so that when fields change, when layers change, which inevitably they will at a nationwide scale, things are happening all the time. The communication is what makes this work. So this is just an example of, your data doesn't have to match NFT by any means. We just pull the core elements in. So the next slide shows the state contributors by data source type. So what we're showing here is all of the data being pulled into NFT. This is the state of the state right now. We did receive a service from Wyoming, so they'll be turning green soon. And there's quite a few folks who are sort of on deck. So, by the next year, they will likely have a service. And a lot of times that's the yellow places. So anyways, it's kind of fun to show folks this map. Next slide, please. So this is just a look at what the NFT Metadata Explorer looks like when folks use it. They can just drill in, zoom in, see an area, check out the data that's available in a given spot. There was someone on the call from White Salmon, so we're zoomed into Mosier here. But yeah, this just it's sort of a data quality tool. We use it just so that folks can take a look when things look off, and it will flag things for us as well. Next slide shows the data source details. So we have a detailed write-up as well as the schema crosswalk for all of the data sources, public or secure, and then a list of all the records coming from the state sources too. So as things improve, this is plumbed directly in with the metadata repository. So as things get updated, these things improve. Next slide. So now we're going to talk a little bit about how this fits into GARP with the last couple minutes. So we aggregate the data from the state databases into NFT, and then certain treatments are automatically pulled into grant accomplishment reporting within GARP. Specifically, those records that have a federal funding program and year, and an NFT completion date, and an NFT treatment category. So you need to have these things in order for the data to flow through. Next slide, please. So these are the grants that GARP supports currently. There's a number of them, and we try to capture in NFT those directly funded treatments from these funds. So directly funded polygons end up in NFT, and those can flow through to GARP for quarterly, biannual, annual accomplishment reporting. Next slide. So this shows you from the whole nation of states that you saw, this is sort of the smaller version of the folks whose data sets are actually capturing all of the correct fields that we need to aggregate them into GARP. So if you click once, I think there's an animation on this slide. So a good example of just because you're fully ready to integrate with GARP and you have a data connected and the schema is crosswalked, it doesn't mean that you have all the data that is required. Even like the fields might match up, but you might not be filling them out. And so the case of Idaho here is they don't have completion dates on a lot of their treatments, and they know it, and they're working on it, and they will eventually get there. So they are ready to integrate, but they don't have anything in there yet. I am running out of time, so I'm going to just skip forward now. This shows where the treatments end up once they've been reported as accomplishments to federal data sources. And so it shows you an even smaller amount of locations where fuel treatments that were directly funded have been reported. And over time, this data is very young right now, but over time, we hope that this fills in and adequately captures the state of the nation with regards to federal funding for state fuel treatments. And next slide. A last note here as I try to wrap this up, we do share in the metadata explorer, we rank everyone's data against one another for how with regards to how complete it is, and it gives people targets and places where they know they can improve their data set. One more slide. So we envision the potential use for NFT to be many. GARP, though, is just a data consumer. So NFT functions without GARP. Shared stewardship is a really good thing to have as people are planning CWPPs, additional treatments, whatever it may be. So GARP benefits from NFT, but NFT does sort of live alone. And we do integrate and have plans to integrate. We hope one day that the NFT data is rolled up into the integrated interagency fuel treatment service. That's been sort of on deck. I know LANDFIRE, we've been in talks with them. TWIG or the Reshape project, they integrate with us too. Like there's lots of good movement in this space. So with that, I'll wrap it up with a few resources. You can take a look at NFT by going to the NFT contributor engagement website, nft.garphub.org. We also have a link to an external publicly available service that folks can look at. Again, that is nationwide. The data quality is a little variant state to state. So just be cautious with that. Kind of helps to drill into an area.
Hey, my name is Aidan Franko. I am the communications manager for the Southwest Ecological Restoration Institute's Reshape program. I'm filling in for our program director, Aaron Kimple, today, and I will be talking about our tool TWIG, the Treatment and Wildfire Interagency Geodatabase. Next slide. So I'm just going to quickly run through exactly who SWERI is and what the Reshape program is. So, like I said, we are the Southwest Ecological Restoration Institutes. We're a group of institutes throughout the Southwest. We're congressionally funded, and we were given a directive to compile and display existing information on fuel treatments and wildfires at the national level and make it really accessible. So this is how the Reshape program was born. We are the SWERI program to meet that congressional directive. And we created TWIG, the Treatment and Wildfire Interagency Geodatabase, which has both a geodatabase portion and a viewer component where we have compiled the systems of record. Next slide. Okay, so now I'm going to really dig into the data. So the systems of record, FACS, NIFPORs, IFPERs, have historically been kind of siloed and not super comparable. So we were tasked with this accessibility, comparability task. So we took TWIG takes from FACS, hazardous fuels that was talked about in the beginning, and pulls that into TWIG, as well as FACS common attributes. We bring in a subset of FACS common attributes. So we have a rule set that looks through the different attributes in FACS common attributes and sorts out things that make a big impact on forest structure and will therefore impact fires. And we pull those into TWIG as well. We also have both NIFPORs and IFPERs data compiled into TWIG. We still have NIFPORs data incorporated to maintain the historical record and consistency, especially with that little overlap of time where both were being used. We also have, as was just talked about, we've been pulling in partnership with the National Association of State Foresters and the great team at Timmins, some of the state data and NGO data that they have available, and this is now in TWIG as well. So that data is currently viewable only, but will soon be downloadable. All of our data automatically updates on a regular basis, just like the systems of record do. One of the main things that TWIG does is when it's pulling in from FACS, NIFPORs, IFPERs, NASF, is that the data is automatically crosswalked. So all of those attributes that may be different across the systems of record are made comparable, and so is the metadata. So this really makes it easy to use on your end. We also do some error flagging. So instead of making any changes to the data, we just flag any things that look like errors so that people can see that on their end. So this includes duplications, any funding anomalies, things like that. We also pull in wildfire data from across the country from WFIGs. And that really helps us show those intersections between fuel treatments and wildfires. So if this is your interest, if intersections between fuel treatments and fires is your area of interest, TWIG is the place to go. One of the other things that we do is apply categorization consistency. So there's a lot of categories for fuel treatment types. And so one of the things that we are working on doing is making sure all of those categories are consistent throughout TWIG. In TWIG, it is open access and open source. It is easy to query. All of the data is downloadable. You can download from the viewer itself a subset of the data, or if you want the entire geodatabase, you can get that from our website. We also have some additional layers. This includes wildfire final perimeters, like I was mentioning, MTBS burn severity. We also have a beta tool for daily wildfire progressions data that we've been collecting. And users are also able to upload their own data layers into TWIG so that they can view how those interact with fuel treatments and wildfires. Okay, next slide. So some of the things that make TWIG unique are that it is public, open access, open source. You don't need a login or a government ID to get into it. All of that data crosswalking and error flagging is already done, so the data is easy, ready to use when you grab it from TWIG. Iterative development, our team is really committed. We work with a great contractor, Innovate Inc., to listen to user feedback and constantly make updates to not only the way that the data is organized, but also the user interface and things like that. This intersection identification is one thing that we really pride ourselves on. We want to get at this question of fuel treatment effectiveness. So where those fuel treatments meet up with wildfires, that intersection point is really what TWIG is looking to emphasize and make available for users. We also aim to be a catalyst for data quality through that crosswalking and error flagging. And we're here to support cross-boundary collaborative planning and prioritization. Next slide. Okay, so some of the major goals of TWIG are to inform treatment effects research by making that intersection data easy to find, easy to download, easy to understand, and able to use right away for analysis. We aim to support planning and decision-making by making those conversations about treatment effects, planning, and prioritization easier to have because the data are in one place, easy to find and view, and any user can create reports on TWIG Viewer, can create maps and print those out, and et cetera, for an area of interest. We also aim to bolster communication about work done on the ground. We really hope to help with that storytelling of this is what work has been done, this is how it's interacting, fuel treatments are interacting with wildfires, and get at that kind of return on investment piece that's so important. So at the end of the day, what it really comes down to for TWIG is if you need to ask, did our treatments work? Or if you're trying to plan, prioritize, or communicate about fuel treatments across boundaries and agency lines, and you want that data already harmonized, error flagged, open access, and ready to use. And if your question involves where treatments happened, where fires burned, and where those two things intersected, TWIG is a starting point for that.
Hello, I'm Brenda Lundberg, the LANDFIRE Reference Data Administrator, and today I'm going to be talking to you about the LANDFIRE Disturbance and Treatment Polygons. Next slide. LANDFIRE produces a disturbance and treatment geodatabase, which is a collection of natural disturbance and land management treatment polygons. Next slide. To collect the data we house in the Disturbance and Treatment Geodatabase, LANDFIRE circulates an annual data call letter to federal agency leads on a list of data contacts. Last, LANDFIRE asked for disturbance and treatment data from the previous federal fiscal year to be submitted by October 31st each year. For example, this year we'll be asking for FY 2026 data, which would include any disturbances and treatments occurring between October 1st, 2025 and September 30th, 2026 to be submitted by October 31st. Data acquired from online sources are pulled on November 1st of each year. Next slide. This is a list of national data sources that we compile each year. We get data from NIFC, including Inform. We also get the Forest Activity Tracking System, or FACS data. We pull in the Forest Surface Insect and Disease Detection Survey data. We also pull data from the Interior Fuels Post-Fire Reporting System, or IFPRIS, which is the Department of Interior. Formerly, we brought in the NIFPORS data. And then we also get national data submissions from the National Park Service and the Bureau of Land Management. Next slide. In addition to the national data sources, we acquire data from state and local agencies. The purple colored states on this map indicate places we have received recent state and or local data contributions. The orange colored ones are places we are missing recent state and local contributions, but rest assured we still have national data for these areas. Next slide. Each data set we receive has its own unique format and set of attributes. Therefore, we convert each data set separately into the LANDFIRE format, and during the data conversion process, LANDFIRE event types are assigned to the disturbances and treatments. And once all data sets are in a like format, they then can be compiled and analyzed. Next slide. This slide shows the LANDFIRE format that we convert the individual data sets into. The fields in white are assigned by LANDFIRE, and the fields in blue are populated by data brought through from the source data set. Things included in our data table are unique identifiers for the polygons. We also have disturbance and treatment type labels as assigned by LANDFIRE, and we also bring in the source data set disturbance and treatment type label. We bring through start and end dates where they're available, and we also bring in severity where it's available. LANDFIRE also sends a source code to each data set, and a lookup table is provided with citation information for each source. Next slide. LANDFIRE produces a raw and model-ready version of the data. The data in the raw layer represents a full account of acceptable data processed and compiled by LANDFIRE. These data may include multiple perimeters for the same event, like multiple fire perimeters, for example, or a high degree of overlap between events within a single fiscal year. The example at the top left of this slide is from the raw data, where we have planting treatments that are overlapping a wildfire. We also produce a model-ready version of the data. The model-ready layer has been standardized, so there's one unique event per fiscal year per location. A set of decision rules are applied to correct the overlap, and the example on the bottom left of the slide is from that same area, and it's the model-ready version of the data, where the wildfire, where we only have a wildfire where it overlapped with the planting events. Next slide. To decide which disturbances and treatment to keep the model-ready layer, the first decision rule we look at is disturbance type hierarchy. This is a list of the LANDFIRE event types that we assign to the various disturbance and treatments. The events at the top of the list with the smallest event type code are considered highest priority. When two events overlap, we keep the event with the smallest event type code. For example, from the previous slide where the wildfire was overlapping the treatment planning, we keep the wildfire. Next slide. If the disturbance types are equal, we'll then look at other attributes to determine which polygon to keep. If severity is populated, we keep the most severe polygon. If severity is equal or not populated, then we look at the end date and keep the most recent. If the end date is equal or not populated, we then look at start date and keep the most recent. If start date is equal or not populated, we'll then look at source code, and we keep national data over state or local. And if those are equal, we'll then look at acres and keep the largest. If all the attributes are equal, then the program will just arbitrarily pick one to keep. Next slide. A public version of the disturbance and treatment polygons can be downloaded from the LANDFIRE map viewer, and the full extent downloads are also available on our website. Sensitive or proprietary data are removed from the public version. We currently have disturbance and treatment data available on our website from 1999 through 2024, and the database contains over 2.4 million polygons across the United States and U.S. territories. The updated public version of the data is posted in September of each year, and this September we'll be releasing the LF 2025 data, which will include disturbances and treatments that occurred between October 1st, 2024 and September 30th, 2025. Next slide. The disturbance and treatment polygons as a standalone data set are a very valuable resource. The map on the left shows the public disturbance and treatment polygons from 1999 through 2024 for CONUS. In the last few years, we've also started bringing in some Canadian fire data into the 90K buffer with CONUS and Alaska, which you can see some of that on this map. Both the raw and model-ready layers are provided in the public version of the data. So if you don't like the way we filtered the data for the model-ready layer, we have a raw layer, which contains all the polygons, and you can filter it as you see fit. You can use this data for a lot of different purposes, including analyzing trends over time. The top figure on the right shows an area around Los Angeles. If you look at the green areas and compare it to the figure on the bottom, you can see that over the years, LANDFIRE has tracked many disturbances and treatments in those green areas. There are a couple of green areas circled in red, which we don't have any disturbances reported. But if you bring in the LF 2025 data, next slide, you can see that we picked up disturbances in those areas in the red polygons, and those are from like the Palisades and Eaton fires that were in January 2025. Next slide. How does LANDFIRE use disturbance and treatment polygon data? Well, the model-ready disturbance and treatment polygon layer is an essential input into our disturbance rasters that LANDFIRE produces. The figure on the left shows the model-ready disturbance and treatment polygons. The red polygons are fire, the orange are thinning, blue is clear cut, and pink is insect. The figure on the right shows the disturbance raster layer. As you can see, the polygons have been brought into the disturbance layer. Remote sense disturbances that were not reported by federal, state, and local entities in the polygon layer are also added to the disturbance layer. These added remote sense disturbances are in light gray in this figure on the right. For example, if you look at the gray dots just north of the large fire, kind of in the saddle area, it appears that there were clear cuts on private lands that were never reported. However, LANDFIRE picked them up through our remote sensing process. Other inputs into our disturbance raster layer include fire program data like MPBS, bark, and ravage. Next slide. Along with additional data added, the disturbance product to the disturbance product, image-based severity is also included. In this version of the figure shows severity assigned to the various disturbances. Next slide. And this is just a little key to the severity. Red is high severity, orange is moderate, yellow is low, and the light gray indicates there was no change detected or no severity. Take note of the big red fire on this slide because it does pertain to the next slide. So we'll go to the next slide. LANDFIRE disturbance layer then goes on to inform annual changes to our vegetation and fuel map layers. Here's an example from our FBM40 surface fuel model layer. The figure on the left is from LF 2023. We captured the large fire in the previous slide in LF 2024 data. And the figure on the right is the FBM40 layer from the LF 2024. As you can see in the red circle, we have now captured that fire. It's accounted for in this layer. The more data we collect and receive for the LANDFIRE disturbance and treatment polygon geodatabase, the more accurate our vegetation and fuel maps are. We encourage anyone who manages disturbance and treatment data to submit their data to LANDFIRE.
Hey everyone, thanks for coming today. So I'm going to talk about a user perspective on field treatment data because I am a field treatment data user and I definitely have opinions about it. Anyways, I'm Andrew. I'm a U.S. Forest Service ORISE postdoc working on the Wildfire Treatment Outcomes Project, which is, I'll talk about a little bit in a few slides here, but it's exactly what it sounds like. So there are different kinds of field treatment data users. There's land and fire managers, there are policymakers and non-government organizations and private individuals, all of whom might use field treatment data for different reasons, be it to make legislation or maybe to try to sue a federal agency. But I'm representing the research side of things. Specifically, what many of us are trying to do at this point in time is look at return on investment of fuel treatments. Like, are they giving us what we want in terms of reducing ecological burn severity or other outcomes? So we identify some area of interest. We look at the wildfires that have happened there. We take all the field treatment data that overlapped with those wildfires. We probably clean it up a little bit, and then we turn it into some analysis-ready product. Next slide, please. So this slide serves two purposes. One, shameless plug of the project I work on. Two, kind of illustrate exactly why we would need good field treatment data. So this project I'm working on, the Wildfire Treatment Outcomes Project, it looks at multiple outcomes field treatments may provide. There's the obvious, are they helping reduce burn severity relative to untreated areas? And then there's two more novel ones in terms of quantification. There's our field treatments helping us contain wildfires and our field treatments helping save structures. To assess these outcomes, we want field treatment data that is precise, accurate, valid, high resolution, spatially and temporally. And we want it to be categorizable because there's like a million different kinds of field treatments. And we can't do statistics on that many different categories. Next slide, please. So when this project started, let's say we were thinking about 3 different potential data sources that have been talked about right now. So there's TWIG, which has combined field treatment data sets and past wildfires. That sounds like a great option. There's LANDFIRE, and then there's just the raw agency databases. Can you go to the next slide, please? So we could not use LANDFIRE because it didn't go far enough back in time. And then we're stuck with TWIG or the raw datasets. They're both categorizable. That's great. Could you go to the next slide, please? Because, as I said earlier, we need to go from about more than 100 different categories in federal treatment data sets to a communicable and analyzable number of categories. We also need to account for overlapping treatments. So the way that our project took this on was, next slide, please. We adapted some of Kendra Fallon's work, who was on this call and may still be. Thanks so much, Kendra. This was massively helpful, where you take one of the many different initial categories, you lump them into one of 5, or in Kendra's work, it was 4. We have added a category so that we can use silvicultural treatments as well as field treatments. You look at all the many different ways they can overlap spatially. Think about that last slide I just showed. Oftentimes agencies are retreating the same area, which is good practice, right? And then you have a final category that is based on a hierarchy of what would affect fire behavior. And Kendra did a lot of work here to come up with these initial categorizations, talking to managers who were using the FTEM dataset, which was, and inputting data into the FTEM dataset, which was discussed earlier. Next slide, please. So while TWIG would have been great because it provides everything already mixed together, it was not available when the project began. It is now available, and we are currently not using it because something has come to light, and I'm going to press upon it here because I have an audience and I think it's important, which is there is no way to determine treatment completeness because a lot of the times the polygons that you get in federal treatment data, they are not totally accurate reflections of what happens on the ground. And I'm going to show you how not accurate numerically in the next slide. All right, so these numbers look huge. And that's because there's a little bit of double counting in this data set that I made. It is all field treatments that overlap with wildfires in the Western US 2012 to 2024. Multi-polygons are broke up into individual polygons. So there's some duplication of individual attributes there. So that's why those numbers are so big. But you should still see, it would hold true that there is quite a big difference between the GIS acres, the polygon acres, that many people just use for analysis and research, and what was actually treated on the ground, which is reported in the raw data sets, which is what we ended up using. Next slide, please. So there's a couple different ways to go about, and I'm sure there's an infinite number of ways to go about considering this, but there's two that I'm aware of. There are two papers. One's very recent by Safford and Stewart in 2020 that just came out this year, and there's a paper by Clark Knight came out in 2022 that is very good. You should read it. I have the reference at the end of these slides. If you are doing field treatment analysis, it's got a lot of good insights. And their solution is to weight raster values by accomplished acres. So if it's definitely treated, it's a 1, and then, yeah, you just if there's some uncertainty there, it's less than a 1. You just multiply it by a proportion. Our approach, because in this project, not to get too deep into it, but we're doing point level sampling, we're just removing treatments if they are under a certain proportion and the treatment is a particular size. For example, if a treatment is 100 acres, it needs to be at least 75% treated. To get this important information from the treatment data sets that are available in FACS, this is called number of units accomplished. In NIFPORS, it is called actual accomplished acres. And in IFPERS, I'm not sure what it's called because last time I checked, which was a month and a half ago, you still could not just download it. You can download it through an API, but it's not as complete as NIFPORS going back in time. Next slide, please. And just to talk about this a little bit more, because it's really one of my favorite things right now, let's look and see Kendra's classifications, just the initial classifications. What's the difference between GIS and treated acres in the stacked bar chart? And you can see that it's a lot smaller. And that's definitely something we should all think about when we're doing analysis. And you might be wondering, does it get better over time? If you look at the figure on the right, the dots are coded to, I did 3-year groups, just to not totally overwhelm the eyes here. Is one data set better than another? They're both a little bit wrong. And spatially, they have the right information in there. You just got to use it. And does it get better over time? You can certainly see that there's more treatments occurring over time. And it does look like maybe it is getting a bit better over time, but there's still some differences there. Having talked to Matt Tanzi, who's the FACS coordinator, this is something they're really impressing upon folks on the ground to try to draw better polygons, draw more accurate polygons. Of course, when you are managing land, maybe that's not the most important thing to you, but it certainly makes researchers' lives easier. Next slide, please. So that is, I think, the really interesting parts of our workflow. Other than that, we use kind of what everyone uses. We use the completed date to make sure that we're removing treatments before they occur. We filter out treatments that have some key attributes unfilled. But I'm gonna make a shameless plug. Again, I like doing that in the future, something that would be amazing would be if there was some continuous measure of treatment intensity. And what I mean by that is if it's a silvicultural treatment, if there was some just, we went from 120 basal area of 120 to 60. That would be really nice to have. So just a plug, it would make research using these data sets very meaningful. And I will say that, of course, there's lots of really good research that's been done that hasn't used some of the filtering rules that we use. But hopefully this will improve results in the future. And I think that's my last slide. Yeah, references if you would like to visit any of those papers that I referenced. Kendra's work's great. All of these papers are really, really great, but highly recommend that you read the first two if you're embarking upon field treatment research, maybe for the first time.
Okay, we're going to move to the question and answer discussion portion of the webinar today. And there have already been some great questions put into the Q&A section. So I'm going to go ahead and start with those. A lot of them have already been answered. So if any new ones come in, I'll jump over to the new ones. But to start with, we got a question: is there a visual flow chart anywhere showing the interactions between all these different data sources? Amanda put a resource in the chat talking about IFTDSS. Go ahead, Amanda.
Yeah, sorry. I think that was actually Bree, while she was still on the call. But yeah, check out our IFTDSS Help Desk Center. I guess our help content folks are incredible. But it has all these technical pages on what treatment data we pull in and how, and along with the wildfire sources. So take a look there. And if you have anything else that you want on the chart, let us know and we'll put it in there. I think the next thing was for IFTDSS as well. Does IFTDSS cover non-federal lands and data? So yes, it does. IFTDSS is a full-scale planning tool for analyzing like the effectiveness of fuels treatments across all lands. And it has a lot of sweet decision support, or I guess planning support tools in there, and hooks up to the fire modeling services framework. So you can run FS Pro and a bunch of other modeling outputs to see how to kind of plan for those treatments. If the FTEM, which is a module within IFTDSS, does not have non-federal data at this point. It's a federal fuels treatment effective monitoring tool. So wanted to clarify there. And thanks, Henry, for stepping in there as well.
Perfect. I also wanted to mention that I think there are a lot of other visual flowchart resources out there. We've been working on one as well. We have some information in the data paper that I put in the chat. But if anyone else has information on more visual resources, feel free to chime in too. Otherwise, I'll jump down to the question that just came in. Andrew, could we get into the ballpark by multiplying treatment areas by 26.6/34.5 dimensions, numbers that you mentioned?
Yeah, there's a few different ways to approach this. Like, if you just want to say this is how much treatment happened in a region, uh, I mean, there's definitely attributes in facts. You don't even need to do anything spatial, right? You could just say, okay, region 3, for example, I just want all of the number of units accomplished, just sum the number of units accomplished for everything that's actually a treatment. If you want to do something that is more spatial, like you want to know how much of a wildfire's footprint was treated, there's a couple different ways to go about it. I think the one that I have preferred is just the area of a polygon times the proportion that it's actually treated. That's a way to go about it. Yeah, there's a lot of different ways to do it. Something that gets really tricky is you have all of these different polygons, right? And you're going to turn them into maybe one if they all happen in the same area. So do you just use the accomplished units for the most recent treatment, or do you do some sort of summing for, whatever you determine the lifespan of a treatment to be at? It's lots of options. It's kind of a tough one.
Thanks for taking that, Andrew. We also have another question for Amanda and Patrick on IFTDSS. Can anyone get access to IFTDSS?
Yes. So I was just typing in an account. So I just linked to the IFTDSS Help Center on creating an account. But yeah, as long as you have a login.gov account, you get into IFTDSS. FTEM's a different story. Again, that's for federal employees and selective collaborators. So if you have a federal email, for the most part, you'll most likely be forwarded to your agency admin who will have to let you in. And otherwise, like there's a full review of everyone else who requests access. So more selective, but IFTDSS is definitely more open source and available to folks. So take a look.
Yep, and I don't really have a whole lot to add to that. Most of our user set is federal employees, but we definitely do have a strong component of non-federal users. So it is easy to get access and does get some good usage.
All right, it seems like there was a question about the US Forest data layers no longer being public, or seems like the server is just having an issue moving the GIS data into the Azure cloud. There's some snags, but it should be back online. What's the answer there? There was a question for Kirk in NFT. Are you capturing NGO and non-forestry state agency field treatments data? Kirk, do you want to address that?
Yes. Yeah. So, Gary, thank you for that question. I did try to answer it, but it was a bit long and drawn out. There are some folks on this call who we work with directly in NFT, and this has been something that's come up. Folks that have, contacts in their Fish and Wildlife organization, the state-based Fish and Wildlife organization, and they're like, they're doing treatments, they're funded by some state funding. We'd love to include their information. And so we are always open to onboarding new organizations, and like onboarding sounds very formal, but really just like connecting into whatever data source you have, however we can make it available, and then aggregating that into NFT. I will say that like we started to include the treatment type reported. Originally, we were coercing treatment type into treatment categories and going broad just to make, to kind of simplify the structure. But through the work with the SWERIES and TWIG, we all realized that we would all benefit greatly from knowing what the actual treatment type was. So that is something that we, that we now pull in. But yeah, so Gary, if you have people that you want to connect me with or so, we are trying to expand out beyond just the forestry state agencies where possible. You did see the map, and it is kind of challenging to get everybody on board, and then even to keep the people that are on board connected. We deal with ArcGIS Online items that suddenly become no longer available because the person who owned them has moved on, and they just like either purged the items or reassigned them. And so then they drop from the group that we share with. So there's lots of moving parts to that. But yeah, I know that the Nature Conservancy, that's sort of something that's always floated around, is like, hey, we could probably connect into whatever source they may have. And so we're always trying to expand, and we are always regularly, as the National Association of State Foresters and the funding that goes to the state, we regularly engage with state folks. And so we like to reduce the surface area that state people have to engage with if it makes sense. But like, if we can be the place where other people want to pull data from, then that it helps consolidate the effort a bit. But yeah.
Thanks, Kirk.
And Corey, I don't know if you wanted to respond to NGO data or Nature Conservancy stuff, but I don't. Yeah.
What was the specific question? I didn't see it.
It was just if regarding NFT, I guess it was more a question for me, but like, being from TNC, like as a, in the future, we'd love to connect with you guys, but yeah, I don't know that there's a question, but
yeah, well, I mean, just a quick response is that we are actively engaged in trying to get the Nature Conservancy to, first of all, aggregate its own treatment data and then make it available to others. And so I would just say we're up behind what the Forest Service and the DOI agencies have done in terms of their corporate databases. And that's what we aspire to, and hope to have something that can be sucked into these kind of treatment data aggregation services in the future.
Awesome. Let's see. Kirk, there was another one for you about landscape scale restoration treatments pulled into GARP.
Yeah, I didn't have a good answer for that one. Fortunately, the person who would know exactly off the top of their head whether or not we pull that in or report on in GARP is out right now. My gut response is we don't aggregate that in GARP, but those treatments are included in many of the state agency data feeds or data services that we connect to. So they are a part of the data that lands in NFT. It's just not going into GARP. So.
The next question was, where does TWIG get its wildfire final perimeters from? We get those from WFIGs. And on TWIG in the layers section, next to each layer, there is a little button where you can click and go to the full metadata and the source data for each one. So that is all fully available on our website and through TWIG. The next question was for the LANDFIRE team. Have there been any updates on the no severity calls in the 2024 data? When this person last ingested, 94% of prescribed fire treatments were classified as no severity. Inga, you had an answer to that?
Yeah, I think some of it depends on because we have 3 different disturbance raster layers that we release, and so it depends on which version you're looking at. But yeah, a lot of the remotely sensed severity doesn't pick up the prescribed fire, especially under a canopy. So, that could be part of it. I think we used to just default to low, but we're not doing that anymore. If we don't see it, we're just saying no. So that could be some of the increase that they're seeing.
No,
Okay.
it's
Great. Well, thank you all very much for being here today. Thanks to our speakers and to everyone who helped organize this. It's been a great session, and we hope to see you again soon. Have a great weekend.